punching shear reinforcing at the column is very critical as well, making sure that's well coordinated around the post-tensioning. Anchorage zones, the where we locate the anchors for the post-tensioning tendons needs to be very thoughtful and well reinforced and well detailed, so that we don't get, because there are very high localized stresses in these regions, so we don't get any failures or issues. That has to be very thoughtfully laid out and detailed. The stressing operations, we actually have to go after this is built in the cast. We have to pull these tendons, and the operation of that also needs to be very thoughtfully done, making sure the concrete has enough initial strength to be able to apply those pre-stressing loads. This is just showing an example of what a bonded tendon looks like, anchorage zone, and the hydraulic jack that they use to actually pull those cables. And then lastly, one of the other real critical things that's often, we find in some places in the markets not thoughtfully done, is the shoring and reshoring procedures. Really understanding how the loads are being applied to the slab and how the shoring and reshoring process works to make sure that the floor load is not overloaded. The floor is not overloaded by too much shoring load. This is something we see commonly done incorrectly. The floor is overloaded and it may deflect more than it was intended to. There happens to be concerns about floor deflection when it comes to post-tension slabs, and one of the biggest reasons we've seen of that is improperly done shoring and reshoring procedures. So it's critical that that is thought about throughout the process. So that's thinking high level, post-tension flat slab and reinforced flat slab, kind of anywhere. There are some more specific concerns that want to be thought about a little bit more detail when it comes to using flat slab in a high seismic region, because there are unique aspects. In particular, the slab to column connection needs to be very thoughtfully done. The slab to wall connection, similarly, slab to shear wall connection needs to be thoughtfully done, and how the diaphragm design, so the seismic forces, how the seismic forces in that flat slab make their way into the lateral system, has to be very thoughtfully done. Yeah. So first, the slab to column connection. So punching shear is the term we use about this. So this is what you don't want to have happen. You don't want your slab to punch through your column. That's why they call it punching shear. Most typically also called two-way shear is the term we use to describe the mechanism of getting the load in the floor into the column. It's very critical component in not just high seismic, but in all flat slab design. And the building code gives you methodologies for how to reinforce that section for these forces. One of the ways is to put in-slab ties or stirrups in the slab, in the depth of the slab, to increase that resistance, that punching shear resistance at the column. This is a photo of it in place, where we've done slab ties throughout the slab to reinforce and strengthen that connection. The other way that's more common in the US, or most common in the US, I guess, is stud rails. I don't know if you've heard of this term before. Stud rail is just that, it's a stud that's placed along a steel rail that acts in that vertical shear direction to increase the strength of that connection. Here's an example of in place of the studs welded to the rails around the column to increase the capacity of that connection. So when we talk about it in a high seismic region, there's a lot of guidance about how to deal with this connection. There's a ACI, American Concrete Institute document 421 that's specific, a guide to seismic design of punching shear